Hello and welcome to another ARM software developer breakdown. My name is Robert Wolf, and in this video, Angel Rivera, developer advocate at CircleCI, will continue building out his CI/CD pipelines demo. Now that we've gone through the initial setup, it's time to implement ARM compute within the config file. If you missed any of the previous parts to this series, please cruise on down to the description and find the part that you're on. Okay, Angel, so far it seems like this demo is coming along quite nicely. We covered the prerequisites with getting your CircleCI account set up, cloning your code base off GitHub, setting up the Terraform cloud, and getting your AWS account ready. Then you went over the initial CircleCI setup by walking us through your dashboard. Now it's time to get these configurations in order. The stage is yours. Take it away.
Good, thanks, Robert. So what we're going to do in this section is essentially go over the CircleCI configuration file. And essentially what that file is the blueprint for your CI/CD pipelines within your code repository. This is the file or the template that CircleCI uses to execute. So your pipelines are defined in this file, and then this is the file that CircleCI, the platform, executes when your code changes. Before we get into that, though, I want to kind of discuss the application. This is a simple repository based off of the blog post code example that I wanted you to all fork and use. But this is my version of it. It's a little bit different. But at the end of the day, it's still based off of that code example. So the first thing I wanted to address here is, again, the Node.js application is not the focus here. The focus is the CI/CD pipeline. But I try to keep things simple, and this application is just a static Node.js web app, and it serves up a static page. As you can see, it's a few texts here, a couple of variables with strings that then get rendered on the page. So again, don't focus on this application too much because it's not really that important. The CI/CD pipeline is the focus. So another thing I want to address is the Docker file. So in this pipeline, we are going to be building a Docker image. Now, ARM architectures and x86 architectures are obviously not compatible. So it applies to that incompatibility also applies to Docker images. So when you build a Docker image for an x86 platform, it's not going to work in an ARM platform and vice versa. So one thing I wanted to call out is in your Docker file, if you're intending to, build Docker images for ARM architectures, just be sure that, your inheriting images are leveraging the ARM 64 v8 prefix, right? So basically what's happening here is when you build this Docker image based off of this Docker file, your cache is going to include the ARM images, right, from upstream Docker Hub. So again, just be sure that your Docker file, if you're intending to build for ARM, has that ARM 64 version 8 prefix, and then you're basically basing your new image off of that, and that makes it ARM capable. So now that I've explained the application and the Docker file, let's look at the CircleCI configuration. First thing I want you to notice is with CircleCI, you need to have a directory named .circleci living inside of your code repository, in the root of your code repository, so that CircleCI knows where to look for the config.yaml file. So once you have that directory there, and if you fork the project, it's going to be there. But if you're doing this from scratch, you always need this .circleci folder, as well as the config file, which we're going to discuss right now. Now, this is a CircleCI config file. I have this file collapsed just to show off the different elements within the YAML. Like I explained earlier, the config.yaml file is, or the config.yml file is a YAML file. We use the YAML syntax within CircleCI, but I like to, use the term, it's YAML, but it's CircleCI juiced YAML. So some of the keys and elements within this YAML are specific to CircleCI and will only be kind of processed by the platform in certain cases. So the first thing you want to do is set up a version number on your YAML. This element or this key just signifies which platform is going to process your CircleCI configuration. And when I say platform, I mean the backend platform at CircleCI. So again, this just tells the backend platform at CircleCI that you need to use the version 2 of the platform, or 2.1, I should say, of the platform. The next key here is what we call orbs. And as you can see here, this orbs key is just almost like an import statement. So for those of you that are not familiar with orbs, orbs are packaged up, executable, reusable pieces of CircleCI configuration. So what we've done here is we've streamlined the capabilities of certain patterns, right? So like, let's say if you're going to use Docker or Node.js or Terraform, we've basically taken every general pattern, every kind of command that you would execute, and we've encapsulated them into this thing that we call orbs. So that, again, they can be shared amongst the community, amongst the platform, and readily used. So Docker is a commonly used thing. We've packaged that functionality up into an orb, and now all of the CircleCI users can benefit from that, right? They don't have to write those Docker commands out, which can get kind of confusing and voluminous. And you can do that with all of these platforms. I'm not going to go through every single one individually, but I just wanted to address orbs in a simple manner. So we have our orbs imported. Let's take a look at the jobs. Jobs are really important here. Basically, jobs are the things that get executed within your CI/CD pipeline, but they get executed in more of a group fashion, right? So one of the jobs that I've named here is called run tests, right? And by the way, this jobs key is a list of jobs. So, it's commands that are just grouped again, and they result in a specific thing being accomplished. That's what a job is in CircleCI. This name of the job is just called run test because I'm going to use this to run unit tests. And then the next step in this job is really important. This is what we call an executor key. They come in multiple flavors. In this case, we're going to build our code on an ARM executor, right? Because we need to compile our software and our resources using ARM hardware, or ARM virtualized hardware. In this case, we're going to just use the machine key. Currently, that's the only executor that has ARM capabilities. We are working on, providing more ARM capabilities in the future, but right now the machine executor is what we use to enable ARM execution. The next step here the next key here is a image key, and essentially, right, that's the OS that we need to run on our executor, on our compute node, and we're going to use Linux Ubuntu 20.04 as the image. And finally, this is actually how you define or specify that you want to leverage an ARM resource class, which is basically a compute node type within the CircleCI ecosystem. As you can see, the resource class key needs a value, and that value, if you can tell here, is just ARM, right? So anything that you want to use with CircleCI in a resource class context, if you want to use ARM, you have to prefix it with ARM dot, and then whatever size compute node you want to use. In this case, we're using a medium size compute node. And finally, in this section, we're talking about steps. And steps is essentially a list of commands that will be executed in the run test build job. So this is a good example of one of those juiced up YAML keys that only CircleCI understands, which is the checkout. And this is an alias for, Git cloning code into the runtime. So this is how CircleCI pulls your code changes into the runtime so that it can execute things on it. Here's a good implementation or good example of an implementation of our node orb. So you would prefix it with the node orb, right? And then you would / and then finally just supply the command that you want to execute. In this case, we are executing an install packages command or job. And then these are the commands that we're going to execute within that prepackaged node or job. We're going to install our dependencies, and then we're going to set a cache path, which essentially means the node orb will automatically kick off and take care of caching all your dependencies. So in CircleCI, we have this concept of caching, which helps speed things along within your build pipelines. Again, we're just telling the orb where to cache or what to cache in our system with that line. Here we go. Next step, we're going to run a command called run unit test, right? So essentially, we're just going to run our unit test against the code changes. And it's very simple, right? Here's a command or a list of commands, and we're just going to run the node test framework using Mocha. and it's going to execute my unit test within the system. So the next step here is pretty similar, right? We want to build our Docker image. So this job here will build a Docker image for us based off of the application. Now, in this case, again, I want to use ARM architectures because I want to build an ARM capable Docker image. I'm defining the image again, right? And then once again, I'm just defining the ARM resource class and the capacity for it. And we jump down to our steps again, right? So here's the list of commands that we're going to execute. In this case, I need to use that cool CircleCI alias for git clone, pull down the code. Then this Docker check, right? We're going to start using the Docker orb to build our image. This check is just essentially doing some more of the, hey, is the Docker client installed? Some validation checks to make sure that the environment is ready to build Docker images. Once that passes, then we're off and running, and we can leverage the Docker orb build command to actually build our Docker image. Now, I just want to call out one thing with the Docker build. Obviously, we have to give our image a name. And if you can tell, I'm leveraging the internal CircleCI environment variables. Since we're pushing this to Docker Hub, I have to prefix my images with my Docker Hub username, which is defined in my Docker login environment variable. And if you see anything here, basically, I use the internal CircleCI environment variables to name things. The reason I do that is for consistency, right? So within my pipelines, that CircleCI project repo name will always be present. It's an environment variable that's declared and defined at runtime when your pipeline kicks off. This is a CircleCI centric environment variable and will only exist in that runtime when executed. Finally, we have a tag property property here for our Docker orb. What I'm using here is a simple semver, right, pattern. You could do whatever you want here, but I like to use this pattern. And then the dynamic portion is the pipeline number. This pipeline number is specific to the actual pipeline run. I'll show you in the dashboard where that pipeline number kind of shows up and how it's defined, but it's an identifier for a specific run of your CI/CD pipeline within the CircleCI platform. But now I have everything built or named and ready to go, so I can build. Once that happens, everything builds, and then we call the Docker push, which essentially pushes that Docker image that we just built up to Docker Hub. So it's available for a deployment, right? The next thing I want to talk about is basically the deployment. So what we're defining here, and I'll get into it in the next section, but what we're defining here is the deployment to AWS. So we're taking this Docker image that we built and pushed to Docker Hub. Now I want to make sure that it runs in an environment, right? In an ARM environment, I should say. So again, we're all used to all of these keys. I'm not going to cover them again, right? The cool checkout. This specific command here, or this command, is essentially building, since we're using Terraform Cloud to store our Terraform Cloud credentials, or our state, I should say, we need to, assign a Terraform token to our system, our environment. And what we're doing here is just essentially leveraging that environment variable that we built earlier or assigned earlier within the project, right, to then create a Docker required Docker file so the CLI can authenticate against Docker or the Terraform Cloud, and then provide that interaction, with saving state. Once we have that all defined, we're going to look at the Terraform orb again, right? So again, this is packaged up, clean commands that you don't really have to worry about. You just need to populate some parameters here. In this case, right, we're running the install command. And what we want to do is just install the CLI, the Terraform CLI into our executor, into our runtime. I'm assigning an ARM64 value to the architecture parameter, and then the operating system is Linux. So this will download the appropriate binary. Since we're dealing with ARM, we want an ARM-capable Terraform CLI binary. So once that's installed, we're going to go through the same old channels, right? If you're using Terraform, we're going to initialize our Terraform, which essentially just downloads all of the dependencies that you need for your Terraform to execute properly. Then we're going to leverage the plan command, which just does a quick validation, a simulated graphing of what's going to be created in provisions within our Terraform. And then finally, we're going to execute the apply command. This is how you trigger Terraform to actually, do something, to build something for you. One of the cool things here is the Terraform variable parameter. So I use this to build dynamic naming for my images. And by the way, this is here because Terraform has the capability to create variables within its own file structure or file schema. I'm just feeding new values into that so that, it has a very dynamic way to assign or define Docker images. Now, once this kicks off, it will build all the things in Amazon for me that are, in the Terraform file or in the Terraform code. But I'm not going to cover all that. Terraform is its own kind of beast in that sense. So that might be a different session. But what we're going to do next is look in the pipeline. I have a destroy command here. And the reason I have that is for demo purposes, right? You would not want to leave infrastructure just sitting there spun up and costing you money. So of course I have a destroy command, which is really nice because it will destroy all the bits that Terraform created, which is really, really great for managing infrastructure. So I'm just kind of showing you a little bit about the power of Terraform, the power of infrastructure as code, and how that all works. Finally, I want to discuss the workflow section of the CircleCI configuration file. Now, the workflow section is essentially an orchestrator. And what it's orchestrating is your jobs. So, right, you've defined a bunch of jobs that perform a bunch of commands. The workflows, the key or the workflow section of your pipeline is the way you would trigger those jobs and orchestrate how they're run. So the first thing you want to do is give your workflow a name. I call this a build. You can call it whatever you like. And then the workflow will need a jobs list, right? Because it's orchestrating your jobs. So you go ahead and create that jobs list and then start giving it some jobs to actually execute, right? So the first three here are going to execute simultaneously. And the reason you can tell that that's going to happen is because there is no requires statement like these other two have, right? So requires essentially creates a dependency on a previous job being successfully completed before the next job is executed, if that makes sense. So in this case, this destroy AWS ECS job that we have defined will not execute because it has a require statement. It will not execute until the approve destroy job has been successfully executed. And in this case, the approved destroy job is here, right? So you can see the sequencing. But again, these three are running in parallel concurrently. And by the way, workflows will do that automatically. So if you need some sort of dependency, you definitely have to add a require statement. Now, I've covered pretty much all the important bits of the CircleCI configuration file for this section. In the next section, we'll go ahead and try to deploy to AWS. So we'll kick off this pipeline. And in this pipeline, we're going to deploy this Docker image based on the ARM build that we did in previous Docker job. And then we're going to deploy this to AWS on ECS using Graviton 2 ARM capable compute nodes.
Well, if you enjoy combing through code, I'm sure that was a lot of fun for you. I definitely enjoyed it. And Angel, this demo is really coming along, so let's keep it rolling. In the next video, we'll focus on deployment using the AWS Elastic Container Service, just as Angel mentioned. As a reminder, if you like the video, don't forget to smash that like button, follow our channel, and stay tuned because Angel's demo will continue in the next ARM software developer breakdown.